In this video, I'm going to explain how to find electric field from electric potential. This is the equation to find electric field vector E equals minus del V, where E is electric field, V is potential, electric potential, del is gradient operator. Let's talk about this operator, gradient operator. Del is defined as partial derivative with respect to x, comma partial derivative with respect to y, partial derivative with respect to z. Let's see how to find partial derivatives. Partial derivatives. Let's say we have a function v of x comma y equals 3x square plus 2y. I'm going to find a partial derivative of this function with respect to x, dou v over dou x. We are differentiating with respect to x, so y should be treated as a constant. Okay, so dou by dou x of this whole function, 3x square plus 2y. Open the bracket, dou by dou x, split the differential, 3x square plus dou by dou x of 2y. Okay, in the first term, 3 is a constant. Take it outside. 3 dou by dou x of x square plus, what is dou by dou x of 2y? We are differentiating with respect to x, and y should be treated as a constant. And the derivative of a constant is 0. So this term is 0. Okay, so we have 3 outside. Differential of x with respect to x square with respect to x is 2x. 3 times 2x is 6x. So that's your answer. Dou v by dou x equals 6x. Now let's see how to find the partial derivative with respect to y of the same function. So dou by dou y of 3x square plus 2y. Open the bracket and split the integrals. Dou by dou y of 3x square plus dou by dou y of 2y. In the first term, we have only x at the top, and we are differentiating with respect to y. If you are partially differentiating with respect to y, then x should be treated as a constant. So dou by dou x of 3x square, x is a constant, so x square is a constant, so 3x square is another constant, and dou by dou y of a constant is 0. The first term is gone. The second term, take 2 outside, and dou y by dou y. Dou y by dou y is 1, so the answer is 2. So that's how you find partial derivatives. One more example. Let's say p of x, y, z equals 2xy plus 3y cube plus 4z square. Let's find dou by dou x of p. So dou by dou x of this whole function, 2xy plus 3y cube plus 4z square. Dou by dou x of 2xy plus dou by dou x of 3y cube plus dou by dou x of 4z square. In the first term, we are differentiating with respect to x. Yeah, we have x at the top. Take the constants outside. 2 is a constant, take it outside. Y is another constant, take it outside. Then we have dou x by dou x. The second term, we are differentiating with respect to x. Y should be y should be treated as a constant. So y is a constant, y cube is another constant, 3y cube is another constant. So whole term is 0. Plus again the same. We are differentiating with respect to x. Z is a constant then. So this term will be 0. So answer will be dou x by dou x is 1. So the answer is 2y. Yeah. Let's find dou p over dou y. Partially differentiate with respect to y. So dou by dou y of 2xy plus 3y cube plus 4z square. So dou by dou y of 2xy plus dou by dou y of 3y cube plus dou by dou y of 4z square. We are differentiating with respect to y. So x should be treated as a constant. This term has x and y. So take the constants outside. 2x is a constant. Dou y by dou y. Plus 3 is a constant. Dou y cube by dou y. Plus, yeah, we are differentiating with respect to y. There's no y at the top. So 0. So 2x times dou y by dou y is 1 plus 3 times dou by dou y of y cube is 3y square. The answer will be 2x plus 9y square. Now let's find the final partial derivative, dou p by dou z. Dou by dou z of 2xy plus 3y cube plus 4z square. So dou by dou z of 2xy plus dou by dou z of 3y cube plus dou by dou z of 4z square. Yeah. We're differentiating with respect to z. There is no z at the top. 0. Differentiating with respect to z. There is no z to differentiate. 0. Differentiating with respect to z. The third term. 4 is a constant. Take it outside. Dou by dou z of z square. So that will be 4 times z square is 2z. So the answer is 8z. Okay, so that's how you find partial derivatives. Let's solve some problems. Concept check 3.7. Suppose an electric potential is described by V of xyz equals minus of 5x square plus y plus z in volts. Which of the following expressions describe the associated electric field in units of volt per meter? So we are given potential as a function of x, y, and z. Minus of 5x square plus y plus z. I'm going to multiply minus into the bracket. So we will get V equals minus 5x square minus y minus z. We need to find electric field. This is the equation to find electric field. E equals minus del V. And what is del? del is dou by dou x, dou by dou y, dou by dou z. So I'm going to expand this equation. Minus of dou by dou x of the potential function x cap, so unit vector along x-axis, plus dou by dou y of potential function times y cap, plus dou by dou z of the potential function along z cap, z axis, z cap. Okay, so I'm going to call this equation number 1. We will come back to this equation after finding the partial derivatives. Let's find dou v by dou x, dou v over dou x. So dou by dou x of, what is our potential function? Minus 5x square minus y minus z. So dou by dou x of minus 5x square minus dou by dou x of y minus dou by dou x of z. Sorry. Yeah. We're differentiating with respect to x. Minus 5 is a constant. Take it outside. Dou x square by dou x is 2x minus dou y by dou x. Differentiating with respect to x, so y should be treated as a constant. Differential of a constant is 0, so minus 0 minus, differentiating with respect to x, so z should be treated as a constant, so it's 0. The answer is minus 10x. Let's find dou v by dou y. Same method, dou by dou y of minus 5x square minus y minus z. So dou by dou y of minus 5x square minus dou y over dou y minus dou z over dou y. We are partially differentiating with respect to y, but there is no y to differentiate at the top, so the first term is 0. Minus dou y by dou y is 1. Dou z by dou y is 0. Differentiating with respect to y, and there is no y at the top, so it's 0. Answer is minus 1. This is dou v by dou x. Let's call this equation number 2. This is dou v by dou y. Let's call this equation 3. So we found dou v by dou x, dou v by dou y. We have to find dou v by dou z as well. Okay. So dou v over dou z. So dou by dou z of the same potential function, minus 5x square minus y minus z. Dou by dou z of minus 5x square minus dou y by dou z minus dou z by dou z. We are differentiating with respect to z. First term is 0 because there is no z to differentiate. Second term is also 0. Third term is 1. The answer is minus 1. That is dou v by dou z. I'm calling this equation 4. So we have dou v by dou x, dou v by dou y, and dou v by dou z. Now let's substitute all these partial derivatives in equation number 1. This is my equation number 1. E equals minus dou v by dou x, x cap. Okay, so E equals, this is equation number 1. minus dou v over dou x x cap plus dou v by dou y cap plus dou v by dou z cap. That is equal to minus of dou v by dou x, equation number 2, minus 10x x cap plus dou v by dou y minus 1 y cap plus dou v by dou z minus 1 z cap. Electric field vector, multiply negative sign into the bracket, minus into minus plus 10x x cap, minus into minus will be plus y cap, minus into minus will be plus z cap. That's my electric field function, 10x x cap plus y cap plus z cap. So the answer is D. Another question. Suppose the electric potential is given by the equation V of xyz equals 5x square plus 8y square. What is the magnitude of electric field at the point 3, 5, 2? This is the equation to find electric field, minus del V, or minus of dou V over dou x x cap plus dou V over dou y cap plus dou V over dou z cap. In our function, we don't have z. It's just 5x square plus 8y square. So we can ignore the third term here. Okay. So that's my equation. Dou V by dou x x cap plus dou V by dou y cap times -1. Yeah. Okay, so let's find dou V over dou x. Let's call this equation number 1. Dou V over dou x is dou by dou x of 5x square minus 8y square. Dou by dou x of 5x square minus dou by dou x of 8y square. In the first term, we are partially differentiating with respect to x. We have x at the top, so take the constant outside. 5 is the constant, dou x square over dou x. The second term, we're differentiating with respect to x. There is no x at the top, so it's 0. This will be 5 times dou by dou x of x square is 2x. The answer is 10x. Let's call this equation number 2. Now let's find dou v over dou y. So dou by dou y of the same potential function, 5x square minus 8y square. Dou by dou y of 5x square minus dou by dou y of 8y square. We are partially differentiating with respect to y. There is no y at the top, so 0 minus. We are differentiating with respect to y. Take 8 outside and dou y square over dou y. 0 minus 8 times dou by dou y of y square is 2y. So the answer is minus 16y. Equation number 3. This is dou v by dou y, and this is dou v over dou x. Okay, so let's substitute equation number 2 and equation number 3 back in equation number 1. So E equals minus of dou v by dou x. Dou v by dou x is equation number 2, 10x. 10x x cap plus dou v by dou y is minus 16y. So minus 16y y cap. Multiply negative sign into the bracket. E is equal to minus 10x x cap minus into minus will be plus 16y y cap. Yeah, that's our electric field function, minus 10x x cap plus 16y y cap. It's a vector because we have x cap and y cap. Okay, now our question, we need to find the magnitude of electric field at the point 3, 5, 2. So this is x coordinate, this is y coordinate, this is z coordinate. So let's replace x with 3 and y with 5. That is equal to minus 10 times x is 3, minus 10 times 3 x cap plus 16 times y is 5 y cap. So E equals minus 30 x cap plus 16 times 5 is 80 y cap. That's our electric field vector. We need to find the magnitude. It's a vector. How do you find the magnitude? Use the Pythagorean theorem. Square root of x component square plus y component square. If you have a negative sign, when you take the square root, put this inside a bracket. Or just ignore the negative sign. So electric field, magnitude of electric field will be equal to 85.44 volt per meter or Newton per coulomb. Yeah, that's our final answer. Another question, suppose that the voltage at a point is given by the equation V of xyz equals 8x minus 9y plus 5z square in volts. Which of the dimensions xyz determines the magnitude of the electric field at this point? We have potential as a function of xyz. V of xyz equals 8x minus 9y plus 5z square. We need to find the magnitude of the electric field. To find the electric field function or electric field vector, this is the equation, minus del V. If you expand it, you'll get minus of dou V over dou x, x cap, plus dou V over dou y, y cap, plus dou V over dou z, z cap. Okay, I'm going to find dou V by dou x. Dou V over dou x is dou by dou x of potential function is 8x minus 9y plus 5z square. Dou by dou x of 8x minus dou by dou x of 9y plus dou by dou x of 5z square. In the first term, we are partially differentiating with respect to x. Take 8 outside. 8 times dou x by dou x. The second term, there is no x at the top, 0. Plus, again, there's no x at the top, so 0. The answer is 8 times dou x by dou x is 1, so 8. Dou v by dou x equals 8. Now let's find dou v. Let's call this equation number 1. So dou v by dou x, dou v by dou y. Next, dou by dou y of the same function, 8x minus 9y plus 5z square. Open the bracket, dou by dou y of 8x minus dou by dou y of 9y plus dou by dou y of 5z square. We are partially differentiating with respect to y, so the first term is 0. There is no y at the top. Minus, Yeah, we have y at the top, so take the constant outside, 9 times dou y over dou y. Again, there is no y at the top, so 0. The answer is minus 9. We have to find dou v by dou z as well. Yeah, let's call this equation number 3. Dou y. Sorry, this is, yeah, let's call this equation number 1, this equation number 2, this equation number 3. So dou v by dou z, dou by dou z of the same potential function, 8x minus 9y plus 5z square. Open the bracket, dou by dou z of 8x minus dou by dou z of 9y plus dou by dou z of 5z square. First term will be 0, there is no z at the top, so is the second term, it's equal to 0. Third term will be, yeah, we have z at the top, so take the constant outside, 5, then dou by dou z of z square. Or you can multiply the power with the coefficient, so it will be 10z, same thing here. So 5 times dou by dou z of z square is 2z, so the answer will be 10z. That is dou v over dou z. Let's call this equation number 4. Okay, let's substitute equation number 2, 3, and 4 back in equation number 1. So electric field function is equal to minus of dou v by dou x is 8x cap plus dou v by dou y, equation number 2, minus 9, it's minus 9 y cap plus dou v by dou z is 10z. So 10z z cap. Multiply minus sign into the bracket, so A equals minus 8x cap plus 9y cap minus 10z z cap. Okay, the question is, which of the dimensions x, y, or z determines the magnitude of the electric field at this point? Okay, this is our electric field function. Minus 8x cap plus 9y cap minus 10z z cap. If you look closely into this function, there is no x coordinate here. There is no y coordinate. We have only z coordinate here, right? What does that mean? It means, let's say we have set of coordinates x, y, z equals 1, 2, 3. Okay, some random coordinates. Our electric field vector will be, okay, how do you find the electric field vector? Replace x with 1, y with 2, and z with 3. But we don't have x in our equation to replace it with 1. We don't have y in our equation to replace it with 2 either. But we have z, right? So we're going to replace z with 3. So minus 8x cap plus 9y cap minus 10 times 3 z cap. And 10 times 3 will be 13. Right? So 30 z cap. That's my electric field vector if this is the coordinate. Now I'm going to okay, we have another set of coordinates x, y, z equals let's say 10, minus 2, 5. So to find the electric field vector at this point, we should replace x with 10, y with minus 2, and z with 5. Again, the same function, but we don't have x here. minus 8x cap plus 9y cap minus 10 times, replace y with 5, so 10 times 5 y cap, sorry, z cap. So our electric field vector will be 10 times 5 will be 50 z cap. So that's my electric field when this is the point, these are the coordinates. Yeah, so because we have only z term in our electric field function, only z coordinate is determining the magnitude of the electric field. So the answer will be Z.